Alrighty folks, welcome to the week 9 homework. Today we're going to start out here with problem number 26. And I noticed that a few of the problems here, guys, kind of involve formulas that you will find in section 6.3 in your book, Applications of Percent, including this problem here. Let's read through it first. It says, in one state, a gallon of unleaded gasoline sells for $3.12. This price includes federal and state taxes that total approximately 69 cents. Therefore, the price of a gallon of gasoline before taxes is $2.43. What is the tax rate on gasoline? Round to the nearest 1%. So first things first, guys, we've got a word problem here. So remember, you always want to look for the question in the word problem, right? What value is it that I'm trying to find? And we'll see here we can find the question because it is asked as a question, as it usually is here. What is the tax rate on the gasoline? So we're trying to figure out what this tax rate is, right? When we solve this problem, we get our answer, it should represent the tax rate on our gasoline. So if you look in your book at page 536, at the top of the page in a green box, you will find a formula for finding the sales tax, or finding the tax rate on some sort of sale. All right? And when you look at the formula, you should see the following. You get that sales tax is equal to the tax rate times the purchase price. Okay? So basically what we need to do is we need to find these pieces in our problem, in our word problem, and we need to plug in their values into the correct spots. So we should be able to find a value that represents sales tax, a value that represents tax rate, and a value that represents our purchase price. So our sales tax first. Okay? So our sales tax, our amount of sales tax, how much did we pay in taxes? Well, the problem says right here that this price includes our federal and state taxes that total approximately 69 cents. So $0.69, $0.69, that is going to be our sales tax, the amount of sales tax that we paid. So sales tax is equal to the tax rate. Well, what is the tax rate? Well, if we remember, guys, we specifically looked for that problem, that question in the problem earlier, and that's what we're trying to find. What is the tax rate? In other words, we don't know it. That's where the whole idea of a variable comes in. Let's call this variable x. We don't know what the tax rate is. We're going to have to solve for it. Right now it's x. So we have, finishing up our formula, tax rate times the purchase price. So what was the purchase price of the gasoline? So now make sure, guys, here we do not want to use the total amount for this value. All right? You want to know, what did you pay pre-tax? All right, that's what your purchase price is. Your purchase price is what you pay before tax. Once you add the tax to it, then it becomes your total amount. So before taxes, our purchase price is $2.43. So we have $2.43. Forgot my decimal. Boom. There we go. All right. So this is our formula with all of our values plugged in. Remember, it's sales tax equals tax rate times purchase price. So our sales tax, we paid a total of 69 cents in sales tax, is equal to our tax rate. We're not sure what that is. That's what we're solving for. Right now it's our variable x, times the purchase price, times the amount that we spent on the gasoline pre-tax, $2.43. So now we're ready to solve here. We just need to get this variable all by itself, right? To solve an equation means to isolate the variable, or get the variable all by itself. So why is the variable not by itself right now? What is it connected to? And also, through what operation are those things connected. So notice that our x is connected to $2.43 through multiplication. So to undo that multiplication, we will divide. Okay, so this multiplication by $2.43 is going to cancel out with our division by $2.43. But remember that in order to maintain this equality, whatever you do to one side of an equation, you must do to the other side of the equation. So we also must divide the left-hand side by 243. All right, and now we just have a little division problem over here that we need to do, and we'll use the aid of a calculator. So we have 0.69. All right, 0.69 divided by 2.43, $2.43. And that is equal to 0.28395. So we have 0.28395. And that is equal to, remember, all we are left with over here on the right-hand side is x, right? Our multiplication by 243 and division by 243 cancel each other out. They are gone. All we're left with is x. So there we go. We have solved for x, 0.28395. Just want to make sure that that is correct. 0.28395. Yep. But reading the problem a little bit more carefully, it says that we want to round this tax rate to the nearest 1%. So currently, guys, we are looking at this as a rate. All right, and usually, as long as this number does not represent anything larger than 1%, a rate is going to be any number between 0 and 1. All right, but in order to now look at this rate as a percent, you would need to multiply it by 100, which is the same thing as moving your decimal place to the right 2 spaces. All right, so the tax rate of 0.28395 is the same thing as a 28.395% tax rate. Okay, so this is the numerical representation of our tax rate. This is the percent representation of our tax rate. So notice that these two numbers are different because this one down here contains this percent sign. All right, it's very important to understand that this as a number and this as a percent. Okay, now I did say to round to the nearest 1%. Since we're at 28.3, we will round down to just 28%. And that will be our final answer. All right. So when all is said and done for this gasoline here, the tax was about 28%. Okay. On to our next problem here. This is going to be problem number 27. And this problem is going to involve a formula from page 542. Okay, so the problem first. It says, after flooding damaged much of the crop, the cost of a head of lettuce jumped from 95 cents to $2.10. Wow, that is a big jump. You're already paying double what you had to. Anyhow, it says, what percent of increase is this? Round to the nearest 1%. So once again, it's a word problem, so let's find that question to see what our answer is going to represent. And here's that question. It says, what percent of increase is this? All right, so we need to figure out by what percent did our price increase, right? We went from initially paying 95 cents for a head of lettuce But after we had some floods that damaged the crop, we now have to pay $2.10 for a head of lettuce. That's quite a big increase. Let's figure out what percent increase this is. So as I was saying, guys, if you look at page 542 in your book, all right, towards the middle of that page, you will find a green box that says finding the percent of increase or decrease. And it kind of gives us a two-step process. So it says for step 1, subtract the smaller number from the larger to find the amount of increase or decrease. And then for step 2, find what percent the amount of increase or decrease is of the original amount. So again, you can find that two-step process on the middle of page 542. So step 1 says, first of all, figure out how much you increased or decreased. In this case, our price increased. It went from 95 cents to $2.10. So let's figure out how much is it that we actually increased in our price. Let's clear this. So we're now paying $2.10 for a head of lettuce. Let's subtract away what we were originally paying, 0.95, to see what our total increase was. So that's $1.15 increase. Let's get this written down here. All right, so we have increased. Let's kind of use a little arrow here to say we've increased by $1.15. Okay, so now the question becomes, $1.15 is what percent of 95 cents, the original cost that we had before the flooding caused the increase. So $1.15 is what percent of 95 cents. All right, well, we can set ourselves up a little bit of a proportion. We know that, we know that 95 cents, all right, we can consider this 100% of our original cost, which tells us then that $1.15 would be what percent? All right, in other words, what percent increase is that going to cause? So we can cross multiply here. 0.95 times x. That's just going to be 0.95x is equal to, and we have to cross multiply on the other diagonal, 1.15 times 100. Just move this decimal twice to the right, and we get 115. So our next step then is going to be to solve for x. We would have to divide by 0.95. Divide this by 0.95. Over on the left-hand side, the multiplication by 0.95 cancels with the division by 0.95, and all we are left with over on the left-hand side is x is equal to, and now on the right-hand side we need to divide. 115 divided by 0.95. So 115 divided by 0.95 equals. So we have 121.0526. 121.0526. Okay, and that is our percent. Just because remember when we set up this proportion here, we said that our original cost, 95 cents, that was 100, I should have put a percent sign here, that was 100% of our cost, and that increased by $1.15. So that's what percent increase, right? So we were solving for an unknown percent. I do believe it says to go to the nearest 1%, so that would be 121% as your final answer. All right, a couple more problems here for our next video, guys, so tune into that, please.